Okay, so next we are going to move into what's going to be evaluating expressions. So a lot of that order of operations is still being used here. So we're still practicing it. We just add another layer to this. So when we evaluate an expression, what it says here, we're evaluating with substitution. So what this means is we're going to have variables now. But what we're going to do is we're going to give you a variable initially, but we're going to fill in that variable with a given number. So we're going to substitute our variable for a number. Then we're going to go through your order of operations and simplify. Okay, so just a little bit of terminology. So when a letter is used to stand in for a variety of numbers, so not necessarily a single number, what it means is so variable derives from vary. There's something that changes. So when we talk about a variable, we're just using something to substitute the variety of numbers we can put in there. And usually what we use is just a letter. So when a letter stands in for a number, that's when we call it a variable. If a letter stands in for only one number, then it's called a constant. So we'll kind of see what that means here. So if it's a number that we know what changes, then it's a variable. If we know it has to be something in particular, then it's going to stay, we call it a constant. So in an algebraic expression consists of variables, numerals, and operation signs, such as your plus, minus, multiplication, and division. So you need to have your operating signs are the big part what makes an algebraic expression. So it has to have operators to be an expression. It's, well, part of it. It could also just be just a variable, and it could be just a number. So when there is an equal sign in between two expressions, then that's when it's an equation. So what we're saying here is that if I wrote 3 times 5 minus 2 is, oops, sorry, wrote just that, that's an algebraic expression. Let's try to write an equation there. Then if I write, let's say, what's that? 13. Let's say if I write 13, 13 itself is also an algebraic expression. Also, if I had something like 2x plus 5, that itself is an algebraic expression. If I just have a variable by itself, just y, that is also an algebraic expression. Sorry. I might be slightly dyslexic. I keep writing things backwards. Okay, so like I said, it could just be numbers and operators. It could be just a number. It could be numbers, variables, and operators. I'm gonna make that a fancy looking X so we know that's a number, a letter. Or it could just be just a letter, just a variable. If you want it to be an equality or an equation, we have two expressions like this. So the 3x minus 2 and the 13. Those together, if I put an equal sign between them, now it's an equation. Right, 2x plus 5 equals y. That is also an equation. So all an equation is just you just take two expressions. Fancy X. So it doesn't matter which two expressions I put together, we make an equation out of it. Now, whether it's equal or not, that's a whole other thing. Okay. So like I said, examples of expressions. So we got a couple operators going on here. So if we this was what we were doing with our order of operations, simplifying these. So we were simplifying expressions. If I throw a variable in, then we really can't simplify too much. Order operations are still applied. It's just a little different here, but we'll go through that later. Like I said, it could just be a variable. It could just be a number. It's just when we combine these together, two expressions, and put an equal sign, then we get those equations. So when we replace a variable with a number, we say we are substituting for the variable. So carrying out the resulting calculation is called evaluating the expression. So let's say I had 3x minus 5. Now, if I said, I'm going to say x is now 2. So when we substitute, what we mean is we're going to do this. I'm going to take that 3, and now where I had an x, I'm going to substitute that 2 back in. Because the other thing we know that x can be is 2. So that is all we mean by substitution. Now, if I want to evaluate the expression, that is equivalent of saying we are just going to simplify. With order of operations. So 3 times 2 is just going to be 6. I was trying to write there. And then 6 minus 5, that's 1. So this is what we mean when we're talking about evaluating algebraic expressions, is we are going to substitute in a number, and then we're going to simplify it. And ideally, we simplify it down to just one number. Okay. So for an example, if I have x minus y, or I say I want to evaluate x minus y for x equal to 88 and y equal to 62. That's going to, 88 is going to replace that x, 62 is going to replace that y. So this is just 88 minus 62. And now by order of operations, this is just going to simplify to 26. So this is what we mean when we're talking about evaluating expressions. So just another example, I have x over y now. We're told that x is negative 81 and that y is now going to be 9. If I simplify this, this should just leave me with negative 9. Okay, so I made these a little progressively a little more difficult as we go through, but just on your worksheet. So for number 4, you're just going to evaluate this. So this one, you only have to replace one variable. Here, remember, all of your x's get replaced with that negative 2. So I always suggest that when you're replacing your variable, put parentheses around it, just because, like in this case, this is negative, you're going to see that we need to put those parentheses around it so we're knowing how we're dealing with a negative number. Same thing here. Here we got 2 variables that we're replacing. So every x is replaced with negative 2, every y is replaced with 3. And I'm emphasizing every variable because I've seen people not do every variable. Oops. So please take a moment and just work on those. All right, so for A, we have 2x minus 7, and we say x is 3. So we're just going to replace that x with a 3. So it's 2 times 3 minus 7. By order of operations, we know that we're going to do 2 times 3 first because that's multiplication division. So we get that 6 minus 7. Then we can do the subtraction. So 6 minus 7 leaves me with negative 1. So for B, all my x's are replaced with a negative 2. So any place I have an x, I'm just going to put some parentheses there. And know that what we're doing is all these places are now they're like empty spots, and we're just putting something in there so that empty spot is filled with a -2, because that's what we said it can be. So this is why I use those parentheses, because this is -2 squared. So that means the -2 is being duplicated, not just the 2. So it's -2 times -2. So we know that's +4. So I did my exponent first. Now, like I said, this is not a grouping. So I said to be a grouping means there need to be operators in there. This is just a single number. We're using the parenthesis to signify multiplication. So I did my exponent first. Now I do my multiplication. 3 times -2, which is going to be -6. So now I'm keeping those parentheses once again just to signify that there's a negative here. So frequently there's negatives, we keep parentheses. 4 minus -6, because going left to right, that's what we come across first. So remember, that's the same as 4 minus 6 minus that 4. So 4 minus 6, -2. And then -4 one more time. Leaves me with -6. Okay, so my answers here, if we were to write these, when we're asked to evaluate, we're expecting to get a single answer like this. So for C, I'm going to write this all from here. C, I said my X is replaced with a -2, so I'm going to put a parentheses -2. Then my Y is replaced with a 3. Then we get here, we got an X again, so that is a -2 again. We got a Y, and that's a 3 again. So we got multiplication, 2 times -2, -4. So that's the first going left to right. The next one is going to be this -3 times 3, -9. Then -2 times 3 is -6. -4 plus 9 is -13. And -6, this is going to be -19.